The ocean never stays still. It wiggles, rolls, crashes, and occasionally looks like it's auditioning for a disaster movie. And the strange part? All that movement is happening without the ocean actually going anywhere. No legs, no engines, just endless motion. So who started it? What invisible force keeps the sea in a constant state of dramatic overreaction? And why does a calm beach one day turn into chaos the next, with absolutely no warning? I'm Professor Everything, and today we'll be answering the question, what causes waves in the ocean? Right here on Explaining Everything. Let's start with the biggest culprit, wind. Most ocean waves exist because wind simply refuses to mind its own business. When wind blows across the surface of the ocean, it drags against the water. Air moving over water creates friction, and that friction transfers energy into the ocean. At first, this energy makes tiny ripples, barely noticeable, kind of adorable. But as the wind keeps blowing, those ripples grow. The stronger the wind, the longer it blows. And the more open water it travels across, the bigger the waves get. The ocean is basically being bullied into motion by the atmosphere. And here's the fun part. The water itself isn't traveling forward with the wave. Individual water molecules mostly move in small circles. The wave is energy moving through the water, not the water packing its bags and going somewhere. So when a wave crashes into shore, it's not water from the middle of the ocean arriving to say hello. It's local water responding dramatically to energy that traveled a very long way. In other words, waves are gossip. Wind starts it, energy spreads it, and the shoreline hears about it last. Now let's talk about three factors that decide how big a wave gets: wind speed, duration, and fetch. Wind speed is obvious. Faster wind means more energy. That's like the ocean being shoved harder. Duration is how long the wind keeps pushing. A quick gust might make ripples. Wind that sticks around for hours says, "No, we're doing this now." Fetch is the distance the wind travels across open water without hitting land. The longer the fetch, the more time waves have to grow. This is why the open ocean can generate massive waves, while a small lake mostly just looks annoyed. Here's where it gets interesting. Waves don't immediately disappear when the wind stops. Once formed, they keep traveling across the ocean, sometimes for thousands of kilometers. That's why a perfectly calm beach can suddenly have strong waves. It's receiving energy sent from a storm far away. The ocean remembers. It holds grudges. It absolutely will bring yesterday's drama into today. Not all waves come from wind. Some waves are born from chaos. When the seafloor suddenly moves during an earthquake, volcanic eruption, or underwater landslide, it displaces a massive amount of water all at once. That water has nowhere to go but up and outward, creating powerful waves. These waves don't start tall. In deep water, they can be long and sneaky, barely noticeable at the surface. But as they approach shallower areas, they slow down, pile up, and suddenly become enormous. This isn't the ocean gently rolling. This is the ocean reacting instantly to the ground beneath it, moving without permission. The key difference here is speed and scale. Wind waves build gradually. Seafloor waves appear because the Earth itself decided to move furniture without warning. Now, let's talk about the moon, because it absolutely refuses to stay out of ocean business. Even though it's nearly 400,000 kilometers away and just floating there, looking harmless, the moon's gravity is constantly pulling on Earth's oceans. This pull creates huge bulges of water on opposite sides of the planet. And as Earth rotates through these bulges, coastlines move in and out of them, giving us tides. Now, tides aren't waves in the usual sense. They're not ripples or rolling crests traveling across the ocean. They're more like the ocean slowly breathing in and out. But even though tides aren't waves, they have a big influence on how waves behave once they reach the shore. When the tide is high, there's more water depth, which lets waves roll in farther before breaking. When the tide is low, waves feel the seafloor sooner, slow down, steepen, and crash earlier. Same waves, completely different attitude. The moon doesn't create everyday waves. That's the wind's job, but it decides how much room those waves have to show off. It's the reason the same beach can look calm and gentle 1 hour, then suddenly turn dramatic a few hours later, without the wind changing at all. So, what causes waves in the ocean? Most of the time, it's wind transferring energy into water, patiently building motion that can travel across the entire planet. Sometimes, it's the Earth itself shifting beneath the sea. And quietly, constantly, the moon pulls on everything like it owns the place. The ocean isn't restless because it wants to be. It's responding to forces above it, below it, and far beyond it, turning invisible energy into visible motion. So next time you watch waves roll in, remember, you're not just looking at water moving. You're watching the atmosphere, the planet, and gravity all arguing at once, and the ocean being forced to show it. If you enjoyed this video, or if you now want to go skinny dipping in the ocean, leave a like and don't forget to subscribe. Also, if you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. If you enjoyed this video, please check out our other binge-able channels. Thank you for tuning in, and join us next time here in the channel that answers all the why, what, who, where, and how questions you've always wondered about, here on Explaining Everything.